Hello children, let's continue solving the sums from chapter number 3, pair of linear equations in two variables. In the previous video lesson, we completed the sums from exercise 3.2. Today we are going to begin with exercise 3.3. So this is question number 1 from exercise 3.3. There are various methods to solve linear equations in two variables. Out of all the methods, in the previous two video lessons, we have learned solving the pair of linear equations by graphical method. And exercise 3.3 is about solving the given pair of linear equations by substitution method. So let us understand what is this substitution method. So we are starting from question number 1 and second from that. S minus t is equal to 3 and s upon 3 plus t upon 2 is equal to 6. Keep in mind, it's not necessary that the variables will always be x and y. It can be any variables, and here the two variables are s and t. So we will consider s minus t is equal to 3 as equation 1 and s upon 3 plus t upon 2 is equal to 6 as equation 2. Now in substitution method, what you have to do is you have to substitute for any of the variables. Either s or t, we have to substitute the values. Now in such cases, what you have to do, you have to select the simplest equation. So in our case, equation 1 is a simple equation. So I can make changes in that equations easily. So from this equation 1, that is s minus t is equal to 3, I can write this equation as s is equal to 3 plus t. So this value of s from equation 1, now I'll substitute in equation 2. So I will have all the variables in equation 2 as t. So it will become a linear equation in one variable. So I can find out value of t from that equation. So let's see this. We will substitute s is equal to 3 plus t in equation 2 and let's see what we get. So s upon 3 plus t upon 2 is equal to 6. This is what is our equation 2. In this equation, we are substituting the value of s as 3 plus t. So look over here. So the equation will become 3 plus t upon 3 plus t upon 2 is equal to 6. Now this new equation we have to solve. So how will you do that? We will cross multiply 3 plus t into 2 plus 3 into t or t into 3 upon 3 into 2 is equal to 6. Alright, let's solve this. So we will have 3 into 2 is 6. 6 plus 2 into t, that is 2t, plus 3 into t is 3t upon 6 is equal to 6. Solve it once again. So we will have 6 plus 5t upon 6 is equal to 6. Shift this 6 to the right hand side. So we get 6 plus 5t is equal to 6 into 6. Again simplify it. 6 plus 5t is equal to 36. So 5t is equal to 30 and therefore t is equal to 6. Now we got the value of t from equation 2. Let us substitute this value of t in any of the equations, either in 1 or 2, and so we will get the value of s. So what we'll do, we'll put t is equal to 6 in equation 1. Our equation 1 is s minus t is equal to 3. If we put t is equal to 6 there, we get s is equal to 3 plus 6 and 3 plus 6 is 9. So value of s is 9. Thus we can find out the value of both the variables in the given pair of linear equations by substitution method. And in our example, we got the value of s as 9 and value of t as 6. Okay. Let's see the other example. This is question number 3 from exercise 3.3. So look over here. We are given two equations. We will consider 3x minus y is equal to 3 as equation 1 and 9x minus 3y is equal to 9 as equation 2. Now for substitution method, you can select any of the equations so that you can substitute either for the value of x or for the value of y. Now in this example, if you observe in equation 2, if I take 3 common, so what do I get? By taking 3 common, you get 3 outside the bracket. In the bracket, 3x minus y is equal to 9. If you solve it, what do you get? 3x minus y is equal to 9 upon 3. 9 upon 3 is 9. So you get 3x minus y is equal to 3. Now check out equation 1 and this new equation which you got. You will observe that equation 1 and equation 2 is the same. Alright, now if both the equations are same, that means the given pair of linear equations, they have infinite values of x and y. So there is no need for us to solve this because both the equations looks absolutely similar. So we just have to write down that x and y, they have infinite number of values. So this pair of linear equations, they have infinite number of solutions. So if you plot it graphically, how will you get the graph? The graph will be overlapping lines. They will be coincident lines. Okay, moving ahead. This is the fourth sum. And little different because you can see the decimal points involved there. So we will consider 0.2x plus 0.3y is equal to 1.3 as our first equation and 0.4x plus 0.5y is equal to 2.3 as our second equation. Alright. Now when you see decimal points, it's always advisable to convert this decimal number into fraction, which will make your sum easy. So how will I write equation 1? You will write it like this: 2 by 10 into x plus 3 upon 10 into y is equal to 13 upon 10. How do I remove the denominator? Because that will make my equation more simple. So I can multiply throughout by 10 and so the 10 will get cancelled from all the terms and finally I'll have 2x plus 3y is equal to 13. So my decimal point equation has changed to a very simple form and I'll give number 3 to this equation. Now I can change this equation because I need to find out what will I substitute. So I am substituting the value of x here. So for that I'll change my equation to 2x is equal to 13 minus 3y. Since I want to substitute for the value of x, I do not want any coefficient along with that variable. So I'll change my equation to x is equal to 13 minus 3y upon 2. So this value of x, now I'll substitute in equation 2. But before that, I will convert equation 2 into simple form like how we did for equation 1. So look over here, we have our second equation as 0.4x plus 0.5y is equal to 2.3. Let's remove the decimal point. So it will be 4 by 10x plus 5 upon 10y is equal to 23 upon 10. If you multiply throughout by 10, you will get a simple equation and that is 4x plus 5y is equal to 23 and we can name this equation or number this equation as 4. Now in the previous slide, we have already found the value of x. That value of x we will substitute in equation 4. What is that value? That value is x is equal to 13 minus 3y upon 2. This value of x we will substitute in equation number 4. So we get 4 in the bracket value of x is 13 minus 3y upon 2 plus 5y is equal to 23. Now here we can cancel this. 2 2s are 4. So what you are left with? We are left with 2 in the bracket 13 minus 3y plus 5y is equal to 23. Now you have to multiply this 2 with the bracket and simplify the equation. So after simplification, what we get is 26 minus 6y plus 5y is equal to 23. Again solve it. Minus 6y plus 5y is minus y. So 26 minus y is equal to 23. And so we get y is equal to 3. So you found the value of y as 3. Now what will be value of x? This value of y we can substitute in any of the equations and we'll get the value of x. So we'll substitute y is equal to 3 in equation 3, and your equation 3 is 2x plus 3y is equal to 13. Let's substitute y is equal to 3 here. So 2x plus 3 into 3 is equal to 13. So 2x is equal to 13 minus 9. 13 minus 9 is 4. 2x is equal to 4, and therefore x is equal to 2, and so we found the value of x as well. So x is equal to 2 and y is equal to 3 is the solution of the given equation. So see children, when you look at the sum, it looks complicated and you get scared. Oh my god, now the decimal points have come, how to solve it? But there's always way to make the equation simple and solve it, and now I hope you understood the method. Anywhere you see decimal point, please convert it into fraction and then solve it. So moving ahead to the next sum now. Again, the moment you see square root sign, there is another fear, but you will find out that it is so simple to solve it. So in this example, we will consider root 2x plus root 2y is equal to 0 as 1 and root 3x minus root 8y as equation 2. So from equation 1, that is root 2x plus root 3y is equal to 0, let's find out the value of x so that we can substitute it in equation 2. So we'll solve it. Root 2x is equal to shift root 3y to the right side, so it will be minus root 3y. So x will be minus root 3y upon root 2. Now this value of x we will substitute in equation 2. So let's start doing it. Equation 2 is root 3x minus root 8y is equal to 0. We have to substitute value of x here, and what is the value of x? Value of x is minus root 3y upon root 2. Let's start substituting. So we get root 3 in the bracket root 3y upon root 2 minus root 8y is equal to 0. Check out, can you cancel anything here? No, you cannot cancel. So what will we do? We will multiply this root 3 with the term inside the bracket. So it will be root 3 into minus root 3y upon root 2 minus root 8y is equal to 0. Now root 3 into root 3, what does it give you? Root 3 into root 3 is 3 and there is negative sign there. So you'll have minus 3y upon root 2 minus root 8y is equal to 0. Now one term has denominator and the other term do not have denominator. So in that case, what do? We multiply the equation throughout by root 2 so that our denominator will get cancelled. So look over here, root 2 into the first term, that is minus 3y upon root 2 minus root 2 into root 8y is equal to 0 into root 2 is 0. So what can be done? This root 2 can be cancelled. So what are you left with? You are left with minus 3y minus root 8y into root 2 is equal to root 2 into 0 will be 0. Alright, so let me write it properly. Minus 3y minus root 8 into root 2 will be root 16y is equal to 0. But what is root 16? Root 16 is 4. So this will give you minus 3y minus 4y is equal to 0. Solve it. That is minus 7y is equal to 0. So what will be value of y? Y will be 0. Now put this value of y in any of the equations to get the value of x. So what do? We'll substitute value of y in equation 1. But what is our equation 1? It is root 2x plus root 3y is equal to 0. Put y is equal to 0 here. So we get root 2x plus root 3 into 0 is equal to 0. Root 3 into 0 will be 0. So root 2x is equal to 0, and so x is also 0. When you look at the sum, looking at square root, you feel like, oh my god, it is so complicated, and the answer has come as 0, isn't it? So we got the value of x and y as 0, and we have made the sum simple. Alright, so please go through the sum once again, and it's not difficult. Let's move to the next sum. This is sixth sum, exercise 3.3, question number 1 and sixth sum. If you look at the sum, you will observe that now the pair of linear equations are given in fraction. But again, as I said, there's always an easy way to convert our equations into simple equations. Let's see how we can do it. So we will consider 3x upon 2 minus 5y upon 3 is equal to minus 2 as equation 1, and x upon 3 plus y upon 2 is equal to 13 upon 6 as equation 2. Always keep in mind that when you are given pair of linear equations in fraction, your first step will always be remove the denominator from the equation. So how do we do that? Look at equation 1. We can do it by taking the LCM, or we can do it by cross multiplication. So have a look at this, how will we do it? So in this case, in equation number 1, 3 into 3x, we are solving it by cross multiplication. So 3 into 3x will be 9x minus 2 into 5y, so we will write like this, upon 2 into 3, so we will write like this, 2 into 3 is 6, and is equal to minus 2 as it is. Let's solve it quickly. So we'll have 9x minus 10y upon 6 is equal to minus 2, and so 9x minus 10y is equal to minus 12. This is our first equation. Look at the first equation given to you and look at the equation how we made it so simple to solve. In the same way, for equation 2 also we'll make it simple. This is equation 2. So again by cross multiplication, so we'll write 2 into x plus 3 into y upon 3 into 2, that is 6, is equal to 13 upon 6. So we'll again simplify this. 2x plus 3y is equal to, we're shifting this 6 to right side. So 13 into 6 upon 6, 6 will get cancelled. So what are you left with? You are left with 2x plus 3y is equal to 13, and we have made our equation 2 very simple once again. So the equations which were in fraction, now we have converted them into the simplest form. So 9x minus 10y is equal to minus 12 is our equation 1, and 2x plus 3y is equal to 13 is our equation 2. Now it's easy for us to solve it by substitution method. So for substitution method, you have to substitute either for the value of x or for the value of y, depending upon whichever equation is simple. But in our case, both the equations are not very simple. Both the equations have got coefficients. So any equation you take, it is one and the same. So what will we do? We will consider equation 1. 9x minus 10y is equal to minus 12. So 9x is equal to minus 12 plus 10y. So x is equal to minus 12 plus 10y upon 9. This is the value of x which we will substitute in equation 2. So equation 2 is 2x plus 3y is equal to 13. And now in this equation, in place of x, we have to substitute its value minus 12 plus 10y upon 9. So let's start doing it. 2 in the bracket minus 12 plus 10y upon 9 plus 3y is equal to 13. Now you will see that we cannot cancel anything. So what do? We will multiply 2 with the bracket and it will solve it. So 2 in the bracket minus 12 plus 10y plus, we'll cross multiply this 9 into 3y upon 3y has denominator 1, so 9 into 1 will be 9. So we have solved it by cross multiplication and it is equal to 13. Now multiply this 2 with the bracket, so it will give you 2 minus 12 plus 10y plus 9 into 3 is 27y is equal to, cross multiply this 9 into 13. So again we will simplify this by multiplying 2 with the bracket. So what do we get? We get minus 24 plus 20y plus 27y is equal to 117. Solve it once again. So it will be this minus 24 minus 117. We will add it, and even 20y plus 27y, that also we will add. And what do we get? We get 47y minus 141 is equal to 0. So 47y is equal to 141, and therefore y is equal to 141 upon 47, and this is 3. So y is equal to 3 is our first solution. We will substitute this value in any of the previous equations and we'll get the value of x. So put y is equal to 3 in equation 2. We'll do that. Equation 2 is 2x plus 3y is equal to 13, and here we will substitute the value of y. So 2x plus 3 into 3 is equal to 13. So 2x plus 9 is equal to 13. So 2x is equal to 13 minus 9. 13 minus 9 is 4. 2x is equal to 4. So x is equal to 2. So x is equal to 2 and y is equal to 3 is the solution of given simultaneous equation. So children, for this particular lesson, practice is the only key. Keep solving the sums and then you will become perfect in solving. You will not go wrong in calculations, because shifting the terms from left to right, multiplying throughout, for removing the denominator, this is all is involved in the chapter. So keep solving, and I hope that when we are doing it on video along with me, you have a pen and a paper and you are solving it along with me. So this is exercise 3.3. This is the page from your textbook. From question number 1 we have solved second sum, third, fourth, fifth and sixth. So question number 1 we have completed. This particular sum seems very simple. I didn't solve it, and this is for your homework. Tomorrow we will start with question number 2, exercise 3.3. So till then, please revise all the sums, and whichever sums we have solved today, I want all of you to keep a note of all these sums in your classwork. So bye and see you tomorrow.